Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Ridhuan bin YUSOF, and today I will talk about the application of oscillator circuit. So what is an oscillator circuit? First of all, it is a mechanical or electrical construction which produce oscillation depending on a few variables. For example, device that need oscillator are traditional clock, various type of metal detectors, computer with microcontroller and microprocessors. So we will explain about the first oscillator circuit, which is RC oscillator. So RC oscillator is a feedback oscillator which consists of amplifying device, a transistor, vacuum tube or op-amp. Op-amp short for operational amplifier. Okay, some of its input energy is fed back into its input through network of resistor and capacitor, which is to achieve a positive feedback and causing it to generate an oscillating sinusoidal voltage. So the application used on RC oscillator, so it can be utilized for generating signals over a wide frequency range. It is commonly used for musical instruments, voice synthesis or in GPS units. So the second one is the LC oscillator circuit. LC oscillator circuit are used either for generating signal at any frequency or picking out signal at any frequency from a more complex signal. It uses positive feedbacks and generates an output frequency without using any input signal. It is a self-supporting circuit which generates a periodic output waveform at an exact frequency. So for the application that uses an LC oscillator, it is widely used to generate high frequency wave that are used in television, radio, high frequency heating or an RF generators. So that is all from me. Thank you.
And good afternoon. My name is AHMAD ZAKI bin LUTFI. Today I want to present about crystal oscillator. What we must know in crystal oscillator is a content. First is definition of crystal oscillator. Second, how crystal oscillator is working. Third, type of crystal oscillator circuit. And fourth, application of crystal oscillator in electronic device. First, what is crystal oscillator? Crystal oscillator is an electronic oscillator circuit that is used for the mechanical resonance of a vibrating crystal of piezoelectric material. Second, it will create an electrical signal with a given frequency. Third, this frequency is commonly used to keep track of time. For example, wristwatch are used in digital integrated circuit to provide a stable clock signal and used to stabilize frequency for radio transmitter and receiver. Quartz crystal is mainly used in radio frequency, which is RF oscillator. Crystal oscillator must be designed to provide a load capacitance. Next, this is example of crystal oscillator. This is in figure show is 16 MHz quartz crystal oscillator. Next is how crystal oscillator is working. As we know, the quartz crystal convert one type of energy into another energy, hence in called as transducer. Two type of crystal oscillator, which is normal crystal oscillator symbol and its equivalent circuit given. Next, series and parallel resonance. This is series and parallel resonance. This is a formula. Okay, to construct the series resonant crystal oscillator, place the crystal element and coupling capacitor between collector and base. Terminal of common emitter configure circuit and we can obtain the oscillator output from collector terminal. For parallel resonance crystal oscillator, the crystal element is placed across the collector and emitter terminal and the output is taken from collector terminal. Here the transistor is configured as common emitter. Next, this is of example of series and parallel resonance. This is crystal in series resonance. It's crystal in parallel. Application of crystal oscillator in electronic device have 4, which is Colpit crystal oscillator application. Colpit oscillator is used to generate sinusoidal output signal at very high frequency. This oscillator can be used at different type of sensor, such as temperature sensor. Next, industrial application of crystal oscillator. They are widely used in computer, instrumentation, digital system, in-phase loop system, and industrial application also used to engine controlling, clock to trip computer and GPS system. Third, in research and measurement, the crystal oscillator are used in research and measurement for the celestial navigation and the space tracking purpose. In medical device, in the measuring instrument. Fourth, in military and aerospace. For the efficient communication system, crystal oscillator are used in military and aerospace. The communication is to establish and for the navigation purpose and electronic warfare in the guidance system. Okay, that's all for me. Thank you.
My name is Ridhuan, Mr. Agustin, alias RAHMAN. Okay, for task 2, you have to design a phase shift or wind bridge oscillator circuit. Okay, this is a phase shift circuit, and you can see I use the capacitor resistor 30 nanofarad and resistor 2.4 kilo ohm. Okay, you can see the result. One circle I get the time 596.591 micro per second. Okay, this is a equation. For theory equation, formula is 1/2 pi RC square root C. Okay, from the circuit, resistor the value is 2.4 and capacitor is 30 nanofarad. And we put in the formula and we get 2.082 kilohertz. Okay, for simulation circuit, formula is 1/time. Okay, for in the result we get time is 590C and 591 micro per second, and we get the answer is 1.676 kilohertz. And last, how to get the percent of difference? Formula is theory, result theory minus result simulation over the result theory, and get 19.5%. Thank you.
Okay, my name is Muhamad SHAMLI. Today I will continue our presentation with design RTC for frequency oscillation in 30 kHz. Okay, for 30 kHz we have used capacitor in 700 microfarad, and our resistor is 3.15 kilo ohm. So this result for 30 kHz. This is calculation for 30 kHz frequency of oscillation. Okay, this is our theory calculation. Formula first 1/2 pi RC square root C, and this is we have put the value 3.5 for our resistor and our capacitor 700 microfarad, and the answer is 29.464 kilohertz. Okay, this is for simulation calculation. Okay, for formula for simulation calculation is 1/time. Okay, time that we have get is 43.56. So this is after we have divided, the answer is 22.956 kilohertz. Okay. Okay, lastly is for theory simulation. This is formula theory minus simulation divided by theory times 100, and we have to put the value. Then the answer is 22.1%. That's all.
Okay, next we discuss about the possible cause of any discrepancy of this result. Okay. So basically theory more accurate than simulation. The reason why, because simulation has crossover distortion, it's caused by circuit installation may affect the result of the simulation. So that's why we make table to differentiate between theory calculation and simulation calculation result. Okay. That's all. Thank you.